We have a dusty mess of an A2141, as they all are. We know Apple doesn't like to cover air intakes or exhaust. They say get all that debris right over everything. This is an A2141. Very likely we're going to have an issue with the SSD controller, as most of these do. So if it is that, hopefully the storage isn't dead and this is fixable. Or maybe it's something else. We'll see. Perhaps a stray capacitor is misbehaving somewhere. I think on this one we're just going to clean it out, take out the board. We already know it's no power. I guess we'll just see. We'll check initially what it's doing once we get the board out of the chassis, but it's dusty. I don't want to touch it. So I'm going to clean it first, and then we'll take it apart and look at it further. This is like a few days later after the last clip, I think. Been out of the office for a little bit. The board on the backside was pretty dusty. I'm gonna just take the board out and dust it a little bit more, but we can kind of see, you know, the usual sort of stuff we'll see on the backside of these boards. Dust builds up, therefore moisture does on the dust, and you ruin components on the backside of the board. I actually haven't even run. Well, I guess we'll see what the board's doing here. But I do see corrosion around this SSD buck regulating. This is probably our issue. I'm just kind of want to get a quick once over on the board. Top side looked, I mean, you know, dusty, but I didn't see any, you know, that kind of like green corrosion buildup that we see on some spots on the backside of the board. Top side, it looks fine. I think our problem is almost certainly that regulator on the backside of the board. Let me just get a, well, I'm going to just clean off this little bit of corrosion right here, the Q-tip. But I think I will just, I'm going to get my thermal cam ready. I assume this is probably going to be drawing enough current and showing me what's bad right about here. We could just check for shorts actually around here really quick. Let me get my multimeter software going here. Okay. You know what? You don't need to get too fancy with these. There was corrosion around the regulator. That's probably it. We have our thermal camera on. I'm just going to do a quick check. Ooh. That's fun. So it actually looks like we have a cap there that is bad. We can see that little guy light up right there. Interesting. Normally you see the regulator fail. Actually, I already got a regulator out because I was pretty confident that was the issue, but I guess not. So I'll put my chip away. What do we have there? Let's see. It's kind of fun. Certainly a lot easier for me to swap this out. 2B5 NAND. Let's see what kind of resistance we're working with here. It's working right now. Okay. Okay, my multimeter software is misbehaving. We can just check our resistance on the line though. Getting 0.42 ohms to ground. That's not supposed to be that. Okay. Let's just knock this off, I think. Or, yeah, we're not too close to the net. We'll go ahead and desolder. I think we should kind of just get some flux in this area and clean it up a bit too. So we'll kind of just swoop some flux around. It does work really well to clean off corrosion. We see this little current sense resistor over here too, which doesn't look terribly happy. Is that kind of blue looking guy right there. We'll put a dime
on our NAND. We don't want to heat that up. Stick it down with some tape, some Kapton tape. Get some tweezers, and we'll start heating. Get this cap off. We'll just go ahead and remove it, and then once we get this off, we'll I guess we'll see what the boil. Knock some things. Whoops. I go to a lower temperature to do this. Get some more flux. Did a whoopsie. It's okay, we'll fix it. Take a deep breath. There we go. Okay. I guess we'll see. Well, let's cool down and then see what it does. Probably will work. We'll see. Had a 2v5 NAND short, and we could see this capacitor getting quite spicy. Not our TPS 62180, surprisingly. Feller does like to die. We don't really care about this cap here. I'd say one of the larger ones. If so, we want to replace it. This, you know, why apply thermal stress to the board if you don't need to? The relative capacitance on the line is quite negligible. You know, we're okay without this. One less thing to blow up on the backside of the board, as it were. Okay. Let this cool down, then we'll be right back. Okay, so we got the bad cap off. Clean up the area a little bit further. And our line, we were at about 0.4, 0.5 ohms. We're at about 65 to 70, which should be good. Generally, we would think maybe dead storage in this sort of failure if we're under 20 or 30 ohms. Voltage cooled down to this point, we can run power into it. And let's see if we get 20 volts. No, we are kind of stuck under this. Oh, there we go. All right, we'll climb it up. This is turning on. Very good. This is turning on. We'll put this back together. I think we're good. I'm just going to do the, you know, we'll get some conformal coating around this regulator to protect this area in the future so this doesn't happen again. Add some blue. And we'll do this on our other regulator opposite side of the board on the top side as well. But we're just going to kind of cover all this stuff right here just because of how much it fails, basically. So we'll kill this with a UV lamp, add some on the other side, and then I think we're good to go. MacBook lives. 2v5 NAND short, basically, on a capacitor rather than the usual suspect, which is the buck regulator. But really, what we just sort of generically see on these a lot is just some part of the edge of the board gets dusty, some moisture builds up, and it kills it. So, you know, another reminder: take your MacBook in to get dusted out every year or so. Basically, all of them have this sort of issue to some degree, where they get dust buildup on the backside of the motherboard. It's not as bad on the newer Pros. I'd say like the newer M2, M1 14, 16 inch. For whatever reason, they don't seem to accumulate as much dust. They're also just not as old though, so that might be the case. This one in particular is just a terrible model for this issue. It just happens so much. Pretty simple fix when it comes down to it. Thermal camera, part got spicy, removed it. There's some years and thinking going on in the background there, but that's more or less the sum of it. A lot of times you might see similar current draw to what this was doing on the onset, which was that kind of like 5 volts spiking up to 0.3 amps or so, and that would be the regulator on the edge of the board, but it wasn't in this case. It was just a single ceramic capacitor. Caused our whole device here to not turn on. Seems to run all good, passes Apple Diagnostics. I think we're good to go. We'll see you in the next video. Hopefully this helps someone.